Okay, I think it's time. Hello everyone. I'm really happy to be here. Talk about JWT. I think we are close to the end of this amazing conference. Congratulations, you are the survivor. First of all, I have a question for you. Who already knows JWT? Can you raise your hand, please? Okay. Well, JWT is now a well-known technology, but I really hope you will learn something with this talk. First of all, I will introduce myself. My name is Karim Pinchon. I'm a French backend developer. You can follow me on Twitter and so on at KPN13. I have a little blog, but only in French. And you can find the following slides on slide.com/KPN13. I work for a company called Fox Intelligence. We build software allowing to analyze e-commerce data, for example, market shares, growth indexes, or any KPIs you might want. I will first introduce some basics. So JWT, JSON Web Token, is inspired by something called simple web token, kind of the same thing, but with the JSON part. It is described as a compact way and secure way to transfer some data, nothing less, nothing more. And there is a lot of implementation in a lot of programming language. Is a JWT a simple string? Well, no. In fact, we can find two families of token. First of all, we have the reference token, which is kind of a simple string, which bear no value, and which only make a reference on something in your system, in your database. And we have the value token, which bears some information, and as you may know, JWT is this kind of token. Fun fact, we can say that JWT should be called JWT, but I'm not sure a lot of people say that. So. Also some basics about cryptography. What is cryptography? It's a mathematical method which will bring some trust in our communication, especially on unsafe channel like HTTP, for example. And it will bring some property, so confidentiality. This is a property which only the receiver will be able to see the message. Authenticity, so we are sure of who sent the message. Integrity, so we are sure that the message has not been modified during the transfer. And non-repudiation, which allow that the sender could not deny to have sent this message. There is a lot of other properties, but only these four will be interesting here. The first cryptography method that we will discuss is digital signature, which will bring integrity, authenticity, and non-repudiation. Encryption will bring confidentiality. All the MAC and HashMAC families, which will bring integrity and authenticity. And encoding, which is not a cryptography method at all, of course. It is just a kind of shift of character registry. It's better to say. So what does it look like? If you never work with JWT, you can see this website, JWT.io, which is kind of a nice UI to play with JWT and to understand how it works. But there is another one, token.dev, which is also which is kind of more powerful, in fact, but less known. So here is a simple example of a JWT. I think this is the most common form of the JWT. And if we had some colors, we can see 3 parts, concatenate with dots. And if we base64 decode this, UL decode this, we'll find this. So 2 JSON objects, a header and a payload, and a signature. Here is just a HashMAC. Something less known, JWT could have different serialization formats. So here is the JSON serialization format. The first one was the compact serialization format. So this is a valid JWT. Of course, it seems to be less useful in an HTTP context, but it has some benefits. Like, for example, you can add several signatures, which is impossible with the compact format. And also, you can have a fourth part, which is the unsecure header. So you can have a header, but non-protected by the signature. Another fun token is this one, an unsecure token. So here there is only two parts, because this token is a valid JWT, but without any protection against modification and so on. So it is supposed to be used only on test purpose, I think, not in production, of course. Another less known is the detached payload token. So here again it's a valid JWT, but only with two parts. The middle part is missing, and so the payload has been sent in another channel, in another way, whatever. And it is the responsibility to the recipient to rebuild the JWT and verify the signature and so on, like always. And the last one, funny also, it is also a valid JWT, but unsecured token with detached payload. So probably not so useful, I think. Let's do a little focus on the header part. The header part is will contain all the cryptography method and keys and etc. you can imagine about the signature of the encryption of the token. So there is a lot of different properties. Of course, you have not to implement all of that, but and I won't explain all of it. But there is a lot of things you can add in the header part. Now the payload part. This is the data you want to send to the receiver, and we can find three families of in the payload. We have the registered claims. So these properties are defined in the JWT specification. It is a good start to implement JWT in your system, and it is really important for security reasons to use it a lot, and I will come back to this later. Then you have the public claims, which are not defined by the JWT specification, but by the IANA. Basically, this is the things who coordinate and name the things on internet, very basically. And in the IANA, you can find some claims defined. I don't know if it's really readable, but for example, if you want to use, I don't know, a first name in your token, in your payload, then I encourage you to stick to this claim for interoperability reason and so on. And if you know OpenID Connect, there is a lot of claims about OpenID Connect defined here. And finally, the third part is the private claim. So you can basically do whatever you want in your token, but keep in mind that JWT should remain compact to be sent in HTTP context. So be careful with that. Now let's talk about JWT. JWT is JavaScript object signing and encryption, and in fact, it's a whole set of specification around JWT. So the first specification is JWT, and in fact, it's defined only how we can exchange claims between two parts and nothing really more. Then you have JSON Web Signature, which define how you can sign your token. And in fact, this is the most common thing we see when we work with JWT. But there is a second implementation of JWT, which is JSON Web Encryption, which defines how you can encrypt your token to have a confidentiality layer on your token. Also, you have a specification only for algorithm either signing algorithm or encryption algorithm. And again, for security reason, I really encourage you to stick to it. But again, I will talk about that a little bit later. And then you have JSON Web Key, which define all the key representation or type of key you might want to use for either signing or encryption. And it's really, again, for interoperability and so on, it is really important to stick to it. There is much more specification in the JWT context, but I will only talk about that. Now let's take a look at JWE, because this is a kind of token we see quite less. So here is a simple JWE, and I set approximately the same amount of data than the previous one. So if we add some color, you can see there is now 5 parts. And we can see also that is kind of bigger, and it's normal because encryption increases the data volume. So let's try to explain what are the 5 parts. You have a symmetric key. You have an initialization vector, you have an authentication tag, you have your payload, the ciphertext, and you have the header. Okay. So to generate a JWE is kind of more complicated than a JWS. First of all, you need to have a symmetric key, which will be used for encryption, for encrypted the payload and the header. By using also an initialization vector. Then, as the result of the encryption, you will have your ciphertext, and so the payload, and an authentication tag, which will be used to validate the encryption. And then, finally, you have to take the public key of the receiver, encrypt your symmetric key, and concatenate all of this, and you have your JWE. I must say that it's only an example because it depends on the algorithm, the encryption algorithm you used. It could be more than that. It could be more complicated than that. And there is a lot of different algorithms you can use. But yeah, this is only an example. Also, like JWS, JWE have a JSON serialization format, and like you can find your 5 parts. Again, it's an example. Also, something less known, you can use nested token. So the most common way you have to use the nested token is first you sign a token, you put it in another token, and you encrypt this token. This is the normal way of doing that. Technically, you can do kind of everything, but this is the basic way. Let's talk about key management. You can represent your key like this. Here is only an example of a representation of a symmetric key. So again, there is a lot of more properties. Here is only an example. So first of all, the algorithm, which will be used with the key. The key type, here is octet, so a simple string. But you can have, I don't know, RSA or elliptic curve, for example. And finally, you have the key. Here you can find a key set, because it's kind of often you have to deal with more than one key. So here is a kind of simple JSON array. Also, something important is the key ID. So you can have an identifier to the key, sorry. X5U is to point a URL to a certificate X509 certificate, or basically a public key. Okay. Here you can also have a URL to a key set. So you can get your key set and with the key ID find the right key and verify the signature with that. Okay, so I just show you some important property, but there is a lot more than that. So let's talk about use case of JWT. First of all, of course, you can use JWT as API token. And as this token is a value token, you will be able, as a server, to verify the signature and so on, and rely on the data in the token without calling any database or something like that. So in terms of scalability and so on, this is quite interesting. JWT is used in OAuth2. OAuth2 is a delegated authorization protocol, and in this specification you have two types. You have, well, let's talk about only access token. So this access token will allow its bearer to access to some resource on the server, kind of an API token, and this token could be either a simple string or a JWT. We talk a little bit about OpenID Connect. OpenID Connect is an authentication protocol. It's built on top of OAuth2 with an authentication layer. And in this specification, you have a second token called the ID token, which will brings the identity of the connected user into your system for SSO, for example. And this ID token is a JWT. Also, a use case is to use JWT as a stateless session. So instead of storing the user session in the server side, in Redis, for example, you can just put all the session data into this token and send it to the client and so on. And so this will be the client who will bear the session. But be careful because it's kind of difficult to kill the session and so on. So it could be kind of tricky. And finally, you can use JWT for kind of everything you want. There is no limited way of usage, so you can imagine kind of everything. This is just a matter of trust and transfer data. Let's talk about vulnerabilities, because has always something which touch authentication, authorization, and cryptography. It is something interesting for a malicious user, I think. So first kind of attack is the unsecured token. Like I said, it is totally okay or valid to have an unsecured token. So with the algorithm is here at none. If your server rely on this part of the token to validate or not the signature, it may allow to pass this token in production. And I think it is an attack that has been exploited, so we have to be careful of that. But now, the good practice is to explicitly authorize this kind of unsecured token to use it. Kind of the same attack, but kind of smarter. Imagine you have a token, a JWT, signed with a private key. So with a RSA, for example, as an attacker, if I get this token, I will just change the header part from RSA to symmetric algorithm. I will take the public key to sign. I will modify the payload, of course. I will take the public key to sign this token, because the public key is, of course, more accessible than the private key. And I will send this token as a server. If I rely on the header part, I will just check, oh, okay, it's a symmetric signature. I will take my public key, because this is meant to verify the signature initially. And then I will find a match between the signature in this token and for what I compute. So I will just allow this token. Also, there is no protection against brute force. So if you get a token and just try a lot of combination to find the signature, you will be able to find the secret if it's too weak and predictable. So, and then be able to forge and sign your own token. We can think that encryption protects against ensure integrity. Well, this is not necessarily the case. In fact, some encryption algorithm doesn't protect against that. So you can have your JWE, modify the payload without having to crack the encryption. It's kind of difficult, but it's possible. And then just send the token. So if you succeed to, I don't know, change a little part of the payload, for example, a Boolean from 0 to 1 for isAdmin property, it could give you some elevated right. So another kind of attack is the substitution attack. If you use a token onto a system which is not supposed to use, you may have again elevated right. For example, I'm a user. I use an application, and for one part of this application, I am a simple user. In another part of the system or the API, I'm an administrator. If I take the token which going to the user part or to the admin part, and I put it in my request to the user part, I will be able to have some elevated right again if all the check has not been done. Yep, sorry. And I will finish that by showing the JWT paradox. You can't trust the token before having verifying the signature. So the header part and the payload part. But you can't really verify the signature without trusting the header for knowing what kind of algorithm has been used, and etc. So, but you can trust the header before the signature, etc., etc. So there is kind of a paradox. I will give some advice to not be act like that. First of all, the secret, as you use a symmetric key or asymmetric key or so on, you have to have a real key policy. You have to use a strong key. You have to rotate your key, etc., etc., etc. You have to keep it secret, of course. Don't accept everything. It's totally okay to outcode some whitelist for algorithm you will be able to handle. For the domain name, you will be authorized for, I don't know, the key set URL or so on. So don't accept everything and don't rely on the header part. Validate all the claims. This is really important to, especially the registered claims. So who is the audience of the token? For whom the token has been forged? Does the token is still valid? Who issued the token? Etc., etc. There is a lot of property you have to validate to be sure that the token is okay, even if the signature is verified. Okay. And also, it's totally okay to validate some private claims for your business logic. Also, be careful against injection, because when you will verify the header part or the payload part, it could happen that SQL or LDAP injection could happen. So be careful for that. It is really easy to develop a little JWS validator. For JWE is quite more difficult, but for JWS it's really easy. But it's also very easy to let some weakness in your code, like for example the unsecured token attack. So don't reinvent the wheel and use a well-known library. There is a lot of libraries in a lot of programming language, so don't hesitate. We can discuss about that, but generally don't trust the header part. Because of what I just said before. Again, we can discuss, choose, but I will always choose asymmetric key against symmetric key. Okay, there is some drawback, but it will be much more complicated to rotate your key and so on if you choose symmetric key, etc. Really, asymmetric key or asymmetric algorithm, etc. Will be much more easy and much more safe for you. So, and my last advice, but again, we can discuss about that. Don't fight for revocation. JWT has a lifetime. If you have really some troubles a lot to revocate some token, maybe you could start by have a shorter lifetime for JWT. But in the real world, we have to deal with revocation, of course. So there is different strategy here. You can have a blacklist, for example. You can just rotate the key, and the token won't be validated again. So, just a few words about privacy. JWS data is totally clear, of course. So don't put any sensitive information in this token, so no password or etc. Don't log JWT, as you won't log any password or API token or so on. And keep in mind that it should remain compact, so put only required and sufficient data, and maybe you will have to increment on that if you really need some more data into the token. So we just saw that JWT is a standard of the industry, of course, but there is also some kind of weakness. But by the way, the weakness are more in the implementation than in the specification. But maybe there is some alternative to that. So I will just present some of them. Maybe some of you knows macaroons, which is kind of an authentication and authorization token to be spread into a microservice architecture. And this is quite interesting in some context. Also, there is something called Biscuit, which is meant to be kind of the best of macaroon and JWT. It is built by a French company, or French team at least. And there is several implementation of Biscuit. I think there is at least a Java implementation, probably a Rust implementation, and Go maybe. Not sure about that, but also someone who hated JWT created something called Passeto, which is kind of the same thing, but without the header part, and he used something different. So there is a draft RFC about that. In fact, I'm not sure it will never be something. It will never be a standard, but there is some implementation, so you can use it, I think. And at the end, I will just summarize. So we saw that JWT, it's only a little part of JAWS. There is several implementation of JWT, so the signed token and the encrypted token. There is a lot of specification around JWT. We talk about just a few of them. And if you want to use JWT, use it properly and securely. So you have to check the claims. It will protect you against substitution. You have to use the algorithm defined in JWA to avoid any issue with the algorithm, and so on. Thank you for listening to me, and thank you for the Vox Day CERN team for their amazing work. Thank you. Yes.
I have a question. I didn't understand the asymmetric to symmetric attack.
Excuse me?
I didn't understand the asymmetric to symmetric
Yeah.
attack.
Okay, I will do it again. In fact, I should just write a schema or something like that. Imagine you have a token signed by an asymmetric key. So, a private key has been used to sign this token. Okay. So, as the server, I rely on the public key to verify the signature. If I am an attacker, I will take this token. I will modify the payload as I want to have elevated rights.
Because first you are going to decrypt it with the public.
No, I just mean for a signing token, right? A signed token, not an encrypted token. Okay. So I modify the payload. I modify the header part to say that it is not signed by an asymmetric algorithm, but by a symmetric algorithm. And I will use the public key to sign this token. So I remove the sign part, and I resign this token myself with the public key. The server will use the public key to verify this token because it expects that token has been used, has been signed by an asymmetric algorithm. But it will rely, if it will rely on the header part, it will just check that it's a symmetric algorithm. So it will use the public key as just a simple string, in fact. And the signature will match and so on. Is it clearer? Okay. Okay. Thank you.